Good morning, dear students. Let's start here the ocean currents. And we are going to see about the currents of the different oceans. First of all, we'll see some important currents of Atlantic Ocean. Then we are going to see about some important currents of Pacific Ocean and some important currents of Indian Ocean. So let's start here with this. And I want to show you first of all this map because this will give you a clear picture. And you can find here this is Atlantic Ocean, and you can find here there are so many currents you can find in this Atlantic Ocean. And from the north, if you'll find, there is a Labrador current. Then between Greenland and Europe, there is a Greenland current. Then there is a Gulf Stream which drift towards Europe and becomes North Atlantic drift. There is a Canary current. Then there is a South Equatorial current, North Equatorial current. There is a Caribbean current. Then there is a Guinea current. In the South Atlantic Ocean, some important currents are Brazil current, and there is a Falkland current. This is cold current, and Benguela current is also a cold current, and west wind drift. So here, if you'll find here, we're going to see these all currents one by one. Right, some only important currents I will tell you. But first of all, if you'll see the red color, that shows the warm current, while this blue color, dark blue or the light blue, they both shows about they are the cold current. Now the one important current I would like to explain you, not one but three currents. And the first one is we're going to see about this is the North Equatorial and South Equatorial current. So you will find here these currents, they usually this picture is not shown properly here, but here it is missing here. But look here, in this Pacific Ocean, if you will find the currents which flow in the close to the equator in the northern hemisphere are called North Equatorial current. So this current you will find in all the ocean, not only in Pacific, the same thing in the Atlantic also, and even in the Indian Ocean. And the same current which flows in the southern hemisphere, that is close to equator, that is known as the South Equatorial current. This is the South Equatorial current, this is the North Equatorial current. Now between these two currents, if you will find, there is a one current, we call it counter current, right? This counter current, it flows on equator and it flows just opposite direction. All the currents you will find, they are moving in the different direction towards the west, but this current, counter current, is moving towards east, just opposite. So what is the reason behind it? So this is why we're going to see here, this I want to explain you, and we're going to see about the equatorial current. So here you can find here this figure 10.6, and here if you'll find here in the northern hemisphere, this current is North Equatorial current, and here this is South Equatorial current in the southern hemisphere. Now why these currents are moving towards west? They are because of the influence of the trade winds. As the trade winds, you can find here, they in the southern hemisphere, they blow from the southeast direction, while in the northern hemisphere they blow from northeast direction. So by this trade winds, these currents, they get energy and they flow towards west. Now what happens here, there is a continent, so with the coastline of continent, they get diverted and they diverted to the equator. But what happens here, on equator, these trade winds, they become very weak. Okay, so these trade winds, they become very weak. At the same time on equator, because Coriolis force also becomes nil. I don't know whether I have explained you or not, but I hope actually in the previous chapter I explained about the Coriolis force, that Coriolis force is nil on equator, but as you move from equator towards pole in the both hemisphere, the Coriolis force keeps on increasing, and on the poles the Coriolis force is highest. Well, this is about the Coriolis force, and Coriolis force also affect all the moving bodies I explained you, and because of Coriolis effect, actually these winds are deflected right hand side in the northern hemisphere and left hand side in the southern hemisphere. You can see these trade winds. Same way, These currents also are deflected in the same direction, right hand side in the northern hemisphere, left hand side in the southern hemisphere. Well, so here what happens, so what happened, because first of all on equator these trade winds becomes weak, first reason. Second, the Coriolis effect is nil, and because of this these currents, they starts moving towards just opposite direction, and they are known as the equatorial counter current. Now this question can be asked, well, question is not given in the exercise, but this is an important question, can be asked in the examination, that why the equatorial counter current, they move in the opposite direction than the other currents. So this is the answer. Now let's see about some more currents. I will explain you, and with the map on the map, and here you will find here this is a south equatorial current, and as it comes close to in the Caribbean Sea, it becomes Caribbean current. Now it is called Caribbean current. Now these Caribbean currents enters in the Gulf of Mexico, and here it is now known as Gulf Stream. So this Gulf Stream, as you can see, it just moves upward, and when it comes near the Newfoundland Island, so what happens, this is the region of westerlies, and as the westerlies blow from west to east, so in the influence of westerlies, these currents, they are drifted towards Europe, and that's why they are now called as North Atlantic drift. This I explained you, that the difference between the current and drift is the currents, the ocean currents which are totally blow in the influence of the permanent winds and same direction, so they are called drift. So here what happened, these currents, they are being deflected towards by the westerlies, and now they are known as the North Atlantic drift. But if you find here, these Gulf streams near the Newfoundland Island, they meet with the Labrador current. Labrador current is a cold current which originates from the Arctic Ocean, and between the Greenland and North America there is one strait is there, narrow water body, which joins Arctic Ocean and Atlantic Ocean, and this narrow water body is known as Davis Strait. So through this Davis Strait, this Labrador current, it enters in Atlantic Ocean. Now here, when these Labrador currents, now how they got the name Labrador current. So if you find here, this part of the North America, what I am showing on the screen, right, this is called Labrador Plateau. Labrador word you may have must be heard about. Labrador dogs are there. So usually the Labrador dogs are the origin of this place, and they are found in every part of the world. This is why now this is the Labrador Plateau on that name, right? So these currents are named as Labrador current. Well, so what happens here, these Labrador currents are very, very cold current. Now when they enters through this Davis Strait, they brings a huge iceberg with them to the Atlantic Ocean, and this is how, if you remember about that very famous accident of Titanic. So Titanic, actually it has collided with the huge iceberg here only close to this Newfoundland Island, and here it drowns. So what happens here, the warm Gulf Stream. Now this Gulf Stream, let me just explain you just small description about the Gulf Stream also. This Gulf Stream is one of the very longest current, and it is warm current, and usually it is very blue color, means the water is very blue, means very, very pure water, and looks like blue water, and this is actually depleted of nutrients. Nutrients means the microorganisms. The microorganisms in the water, in the ocean water, usually they are known as the planktons, and they all again can be characterized into zooplanktons and phytoplanktons, and these planktons actually are the good food. They provide a feed for the small fish. So the small fish usually they feed on the planktons, and the small fish usually are the feed for the bigger fish. So this is how actually there is a food chain is formed, and the smallest part of this food chain is the plankton. So usually in the Gulf Stream, in the Gulf of Mexico, here this region, usually this stream, they are depleted of these planktons, so that's why we call it they are depleted of the nutrients. So in the book you will find it is written here, written there, depleted of nutrients. Well, and this is why very less number of fish usually are found in this region, in the Gulf of Mexico, Caribbean Sea. Usually very few fish are found here. Well, so what happens here now, when the Gulf Stream and the Labrador Current, they meet here. Now if you find here, there is a small island here. This island is called Newfoundland Island. Now when these two currents meet here, they just forms a very ideal condition. So first of all, by meeting the warm and the cold current, there is a large amount of fog is produced, and because of that fog actually, because of that only, Titanic, the captain of the Titanic, he had not seen the iceberg and collided with it. Well, so the fog is a very very important thing you can find in this region. But at the same time, this Labrador Current and Gulf Stream, as they meet together, they provides a very very ideal condition for the growth of planktons, microorganisms. And because of this microorganisms, as I already explained you, that they provide a feed for the small fish. And so what happened, the fish from the both water, from the cold water and the warm water, they both, all the side, they come here. And this is how actually it just forms a very very important fishing bank, which is called Grand Banks, and which attracts the fishermen not only from Europe and Africa, northern part of Africa, but also from North America, even from Caribbean islands. The fishermen used to come here just to catch fish, because this is the biggest fishing bank known as Grand Banks. So this is, we have seen about the important currents, but again you will find here some more currents. Already I had shown you this Greenland current is also a cold current. Now here this current, the Gulf Stream, actually one branch it goes to the north, but one branch it comes down here. You can see here, right, it comes down here and it converts into the cold current. Now this is a Canary current. Now this is very very important. I want to explain you that how, this is not given in the book, but this is important, because you must be thinking that how this warm current is turned into this cold current. Now usually what happen, there are the two currents, usually they flow in the same direction. So if there is the upper surface, if you can find there is a warm current just below in the ocean, there is a cold water is flowing. The only one thing happens, sometime due to some different type of factor, different conditions, what happens, the cold current it comes up and the warm current it's upside down. So usually this is how the warm water it's upside down, and the cold water which is usually blowing below this all this warm current, there is a cold current, cold water is flowing, and on the surface there is a warm water. So this cold water it comes on the surface and the warm water is upside down. So this is how you can find the warm current, it changes into cold current. Here you will find here, this is a Mozambique current from the Indian Ocean, as it takes turn, Agulhas current, and what happens as it takes a U-turn and it just turns into cold current, Benguela current, right? So some more currents, let's see here. In the South Atlantic Ocean also you will find this current. This South Equatorial current is not shown, that this arrow is going up, but one arrow it comes down here. This is the arrow, South Equatorial current, and it turns when it comes close to Brazil, it is called Brazil current. Now this same Brazil current also meets with the cold Falkland current. Now there is one island known as Falkland Island, and here these warm and the cold current meets together, and here also they forms a very ideal condition, and here also this area is one fishing bank. So these are some important currents we have seen here. These are the currents of the Atlantic Ocean. Now let's move to the Pacific Ocean. So in Pacific Ocean also you will find here some part, one part is here, another part is this side near the North America, South America. This is the Pacific Ocean, and here close to this, because this is map is flat. Well, so the half Pacific Ocean is this side of the Asia and Australia, and the half of the Pacific Ocean is on the west side of North America and South America. So here if you find here some important currents, you will find they are the Kuroshio current, then there is the Oyashio current, then some more current, you will find here the North Equatorial current, right, South Equatorial current, this is South Equatorial current, North Equatorial current, North counter current, then there is here is a South Equatorial current come down here, and it's take a U-turn and changes into Peru current, Then in the North Pacific Ocean near California, this is the California current, this is cold current. Then Alaska current, near Alaska it is a warm current. Now near Japan also, if you'll find, there is Oyashio current and Kurile current. There is a warm current, Kuroshio or Kuroshio, it is given in the map. In the book it is given Kuroshio. Both they are the same current. It is a warm current. So near Japan also, what happened, if you'll find here, this is a Kuroshio, which is, you can see here on your screen. This is a warm current. It is also known as Kuroshio current. Kuroshio or Kuroshio, both are the same. This is a warm current. And here from the north, there you can see there is a Oyashio current and Kurile current, they comes down. So near Japan, these two currents, warm and the cold current, they meet together and they forms a very ideal condition, and they forms a big, very important fishing bank. Now this is known as the Japanese coast, because it is found near the Japan. So this fishing bank is known as Japanese coast. This is the second most important fishing bank after Grand Banks. Well, so these are some important currents you have seen here. North and South Equatorial current we have seen. Then California current, Peru current, East Australian current near the Australia, if you'll find here, right? There is a East Australian current here, right? Okay, now let's move to the Indian Ocean. Now in Indian Ocean also, if you'll find, there are some important currents. South Equatorial current here, this is South Equatorial current. This is the North Equatorial current up, and it goes up here, down here. And when it comes in the Bay of Bengal, now they are known as the monsoon drift and monsoon current or monsoon drift. And so they are known as the southeast monsoon current and northeast monsoon current, because they are influenced by the monsoon winds. Monsoon winds, they just change the direction. After 6 months they blow from southwest direction, and for 6 months they blow from northeast direction. That's why they also influence the current, and the current also change the direction with the winds. So this is a very important currents, monsoon currents or the southwest monsoon current and northeast monsoon current. So these are the only current which usually change the direction with the monsoon winds. Well, some other currents, let's see here. This near Mozambique, here is a Mozambique country. This is called Mozambique current. It has come down, it is called Algeciras current. This is all the warm current. Now near the western coast of Australia, you will find here, this is the cold current, West Australian current. So these are some currents which you can find in Indian Ocean. Now let's move to some effect of the ocean currents. So one by one, let's start here. First of all, as I told you, the ocean currents are the important source of temperature distribution. So what happened, as you can already, I have shown you, the warm current, when it moves to the polar region, from the polar region, the cold current, it moves to the equatorial region. So this is how what happened, the cold water and warm water meets together, and they distribute the water in the whole ocean basin. So they are the important source of temperature distribution, and that's why you will find they affect the wind, they affect the climate of the different parts of the continent, countries. Well, another thing, the ocean currents mitigate the air temperature and help in the regulation of the air routes. Mitigation means when the wind, it blows over the cold current, what happens, it becomes cold. And when the wind blows over the warm current, what happens, just opposite, it becomes warm. So when, same way, now let me just show you the map again, and then I will explain you here with the example. So look here the map, and if you find here near this Europe, here is a small island, Great Britain. Now this Great Britain, if you find, this lies in the cool temperate region. So usually this region is very, very cold region. The region here in the Europe and the Russia, it is frozen, means most part of the year. Here also in the North America, Canada and all this region, same latitude, Great Britain is also situated. But here if you find, the temperature is usually moderate. What is the reason? The reason is, here if you find, there is a North Atlantic drift, this ocean current is warm. So the westerlies, when it blows over this warm current, so the westerlies, the wind also becomes warm, and so when they enters in Great Britain, so it also just keeps the atmosphere, keeps the climate warmer. So even this Great Britain and the whole Western Australia, the coastal part of Australia, oh sorry, not Australia, this is Europe, the coastal part of Europe, And same thing in the Australia also. In Australia also, the coastal part of Australia. So I am showing you about the Europe here. So here in the Europe, actually the coastal region of Europe and this Great Britain, they influence the moderate climate. What is the reason? Reason is the westerlies which blow over the warm water, this warm current, it becomes warm, and so it just influences the climate of this whole coastal region and the Great Britain island. Okay, so this is how it mitigates the air temperature. Next is the at the lower latitude, what happened, the eastern boundary, usually you will find there is, I told you about the reversal of the ocean current. I explained you about one thing here. There is one thing here, it takes, I told you about the southwest monsoon current and the northeast monsoon current. These are the only current which reverses their direction. Why it reverses the direction? Because of the monsoon winds. Well, another thing I told you, that is okay, that is important, that thing was left. Okay, now next is the, now here if you'll find, I told you that already explained you about the area, the region of the Labrador current. So where the Labrador current and the Gulf Stream, they meet together, what happened, they makes weather cold and foggy. So what is the reason? Reason is the, that is the two types of currents, they meet together. And especially one more thing happens. Now let me just show you in the map, then you will understand it. Now look here. Now here, look here. Now this is North America and here is California. In California there is one city and that is known as San Francisco. And for this actually I would like to tell you, I think many of you have seen that one movie, My Name is Khan. In that movie there is a one scene is there where the scene is shown from the mountain top and it was all foggy region. Now usually about the San Francisco, one thing I want to tell you, San Francisco is situated on the western coast, and here you will find the, even in the summer season, the weather you can find foggy. What is the reason? Reason is the current is cold current. This is California current, this is a cold current, and the wind blows here is westerlies. So westerlies is the warm winds. Usually the westerlies are the warm winds. So when the warm winds blow over this cold current, what happens? It forms a lot of fog, and that's why here many areas, different parts of the world, wherever this condition applies, when the current is cold and the wind blowing over it is warm, so the weather can be foggy weather can be experienced. Okay, now next point is the, this I explained you, mixing of the cold and the warm current. When the two types of current, warm and the cold current, they meet together, what happens? They create an ideal condition for the growth of planktons, and this is why that forms important fishing bank. Next is the cold and the warm current. When they meet together, they just forms a lot of fog. Because of that only the Titanic, that incident, Titanic drowned there, because the captain of the ship, he has not able to see the iceberg well and collided. Next is the, even the cyclones are also affected by these ocean currents. You will find usually one thing. Now let me just show you again, let me take you to the map here and look here. Now if you'll find here, there are some areas which are usually experience cyclones. Cyclones are very, very common in those areas. Look, this is Gulf of Mexico. This region is very, very common here. The means cyclones every year, it is very, very common. Cyclones are a common thing that occurs here. In Bay of Bengal also, near the Odisha and West Bengal, this region also usually hit by the cyclones. Then again in the South China Sea here, this whole region, right, and up to Japan, this region also hit by the cyclones. Now what is the reason? Now reason is, if you will find here all these areas, you will find the currents, currents is warm. Here also the current is warm. Here is also in Bay of Bengal the current is warm. Here also in South China Sea there is a warm current. This Kuroshima originates from here only. So the currents are warm, and usually the warm currents attracts what? because the currents are warm, means the whole water is warm, and so the atmosphere also is warm above it, and that creates a low pressure, and that low pressure attracts the cyclone. This is why always the cyclone hit these areas, because here is a low pressure created. This low pressure is formed. Why? Because of the warm currents. Okay, now let's come back here. And another thing, so one more thing, the warm and the cold current also, it helps in the rainfall. How the rainfall? Now let me explain this thing also with the map. So look here, the map. So here if you find here this western Europe, it gets very good rainfall. What is the reason? Reason is current is warm current, it creates a low pressure, and this low pressure attracts the clouds. So clouds from any part, they are attracted usually towards the low pressure. So this region gets good rainfall. Here also the British Columbia and Canada, you will find Alaska current, this is warm current, and this region receives good rainfall. So all the regions, most of the regions you will find here, currents also affect the rainfall. And wherever you will find the currents are cold, you will find that region it receives very less rainfall. Well, same that is why you will find here, you will find one thing, the Kalahari Desert, Atacama Desert, all these deserts, how they have developed? Because of the cold current. Now let me explain you. So look here. So here if you find here usually is Kalahari Desert, Namib Desert. Now why these deserts are there? There is a cold current. Water is cold, so they don't allow any rainfall, means there is a high pressure, so it just act as a, means it doesn't help in rainfall, and that's why this deserts is been formed here, this region Kalahari and Namib Desert. The same way here is a Great Australian Desert. Why? There is a cold current, West Australian current. So then next one is the cold current also, like in the Labrador current. Labrador currents is a cold current, and because of this the weather near the Canada is very cold, and very cold winter for the 9 to 10 months. That region is very experience severe winter. So why it is? Because of the cold current. So today only this currents. Now next session we will start with the tides. So all of you read the whole chapter. All the best.